In the summer of 1978, the temperature outside a government research facility in Phoenix reached 104 degrees Fahrenheit. The test room had no air conditioning, no fan, no mechanical cooling of any kind. Yet inside that room, building engineer Harold Fenton recorded a temperature of 81 degrees. He had created a climate 23 degrees cooler than the desert air with zero electricity. This cross-sectional schematic shows the exact setup Fenton used. He placed a small clay pot inside a larger one and packed the gap between them with saturated sand, covering the top with a moist cotton cloth. Fenton documented the results and submitted them to his director. Not a single HVAC manufacturer requested his data, and not one air conditioning company reached out to fund further testing. Fenton's findings sat in a government archive for over a decade without a single commercial citation. His results remained ignored while the global HVAC industry grew into a $240 billion a year business. Today, the average American household spends up to $2,000 a year just on the electricity to run an air conditioner, on top of $10,000 in upfront installation costs. Fenton was documenting a physical principle that dates back 4,000 years, long before modern commercial cooling ever existed. Every civilization that faced serious heat discovered this same method. We currently pay thousands of dollars for a problem our ancestors solved for the cost of a bucket of water. This setup relies on a concept called direct evaporative cooling. It is the core mechanism behind every passive cooling system in history. When hot, dry air passes a wet surface, water molecules absorb heat energy to convert from liquid into vapor. Mathematically, every evaporating pound of water removes 1,000 BTUs of heat, the exact same unit of measurement used to rate modern air conditioners. Thermodynamics ensures this creates real, measurable cooling power using only water and airflow. It is a predictable physical reaction, not a folk remedy. Ancient Egyptian engineers used this to keep palaces 20 degrees cooler than the Nile Valley. They hung wet reeds and moistened linen across doorways to catch the wind and cool the incoming air. In 400 BC, Persian architects built these wind catcher towers. They captured high-altitude breezes and forced them through underground water channels before routing the chilled air into living spaces. 16th-century Mughal palaces in India used wet grass mats placed in window openings to survive 115-degree summers. Evaporation maintained comfortable temperatures in royal rooms, while the outside heat was lethal. Cultures on 3 different continents independently engineered the same solution. They relied on it for millennia because it worked with zero electricity. In 1902, Willis Carrier invented the first electrical air conditioning system. For the first time, cooling became a commercial product, rather than an architectural principle. By the 1950s, residential air conditioning was a status symbol. Windows were sealed, cross breezes were ignored, and passive cooling knowledge began to fade. In 1974, a Department of Energy study confirmed that passive cooling could reduce home temperatures by 12 to 18 degrees with zero energy input. That same year, major HVAC manufacturers lobbied 12 states to restrict what they called unregulated cooling systems. Within 2 years, building permit codes were updated to require licensed contractors for any residential cooling modification. An HVAC industry cannot generate recurring revenue from a method that requires no proprietary parts and zero electricity. By regulating the installation process, the industry made passive methods seem complex, dangerous, or illegal. This technology has one critical limitation. It relies entirely on the local air's capacity to absorb moisture. As this map shows, the effect varies by region. In dry stints like Arizona or Nevada, you can achieve the full 15-degree drop. In high humidity areas like the Gulf Coast, the air is already saturated, limiting the cooling effect to about 6 to 8 degrees. Even in humid climates, an 8-degree drop is significant. But the truly disruptive performance that can replace an air conditioner requires an arid environment. This schematic shows the basic setup. Place a bowl of cold water in front of a window with an active cross breeze and hang a wet cotton towel across the opening. The wind must pass through the wet fabric to cool the room. For continuous cooling, use the nested Fenton setup. Placed in the same window airflow, evaporation from the wet sand provides cooling day and night.
Using these exact methods, an Arizona teacher recently dropped her monthly summer electricity bill from $212 to $31. Thermodynamics hasn't changed in 4,000 years. You now have the knowledge to bypass a $240 billion business model using nothing but a bucket of water.